we are doing 6.4, which is adding and subtracting linear inequalities. And so we're basically, I look at it sort of like translating. So we're translating sentences or English into mathematical equations, and in this case, inequalities. So an equation has an equal sign. An inequality has the greater than or less than sign, and sometimes with a line underneath it to say less than or equal to or greater than or equal to. All stuff we know, right? Okay, so we just want to represent this on a number line. We did this already. You learned it last week through the videos, but basically in order to show this solution, we would write a number line, and this is saying you are able to spend between $2 and $5. So I know on my number line, I need to have a 2 there, and I need to have a 5 there. This is just a matter of translating the words. If it says you are able to spend between $2 and $5, I know I'm going to draw a circle at $2 and I'm going to draw a circle at $5. It's saying in between, so I would sort of attach that or color that in. But do I include the $2 and $5 or do I not? So this is a matter of interpreting the information that's written there. If you are able to spend between $2 and $5, do we color in the circles? Does everybody agree? Yes? Debate? We usually have debate over this. If it says you can spend between $2 and $5, can you spend $2? Yeah, so that means we color in the circles. It can be $2, it can be $5, so we would color it in. Good? So I think it's not so much difficulty, it's more like nitpicky little details. The next one is the temperature will reach 11 degrees maximum today. How do we show that using an inequality? Well, I feel like you guys have got this. On a number line, we know that we need to go up to, let's say I'm going to make that my 11. So 10, 9, that would be 12. I usually like to show some numbers on either side. But if it reaches a maximum of 11 degrees, do we color in the 11 degrees? Yeah, because if it reaches a maximum of that, it could be that. And then how do I represent this? Which numbers is it allowed to be? Yeah, so we draw an arrow going to the left. Everybody good with that? It can be anything below that. It just can't be anything above that. So this is, again, sort of just like translating things. Good? A number is not between -4 and 1. Okay, so it's getting a little more interesting. Well, let's show this. -4, -5, -3, -2, -1, 0, 1. Okay, so not between -4 and 1. So I'm going to put a circle there and a circle there. How do I show this? If the number is not in between those two, could it be equal to -4 and 1? If it's not in between those two? Again, nitpicky details. Well, when it is between something, we do color it in. So if it's not in between them, we don't color them in. Do you get that nitpicky detail? If it's not in between those, which way, what do I do? Where do I draw an arrow? Left of -4, so it is allowed to be anything less than that. And what else? Yeah, and also to the right of 1. Because basically we're saying it can be anything smaller than -4, anything bigger than 1. So this is the appropriate way to graph this out and to show our solution. So far, so good? Questions about anything before we move on? Okay, so here's the thing with this. It says solve and graph. I feel like this is not looking good. Solve and graph this, and it basically looks like stuff we've done before. So this is saying x plus 5 is less than 10. The only difference is we're used to seeing an equal sign here, and this time it's not equals, it's not an equation, it's an inequality, right? We can still go through and solve this as if it's just a normal equation. So we can ignore the less than sign for a bit if we want to, and then we'll take a look at what that means. So if this was just an equal sign, what move would I do next? Snoo? Subtract 5 on both sides. Everybody see that that's kind of like what we were doing before anyways. I want to keep the sign the same. And then I take a look at this and say, okay, those two are gone. I just have an x on this side. And I have over here 10 minus 5. So I have x is less than 5. Good? And then the other thing is if we want to graph that, I would do that. 5, 6. Do I color in the circle? If it's less than, we leave it open, and less than 5 would mean we go this way. So this is how we're going to appropriately graph out what our solution is. Good? Okay, so you know how this goes. We just did a one-step inequality, but now we're going to throw in some other stuff. How about if we have 9 minus x is all greater than negative 2x plus 1. We've still done stuff like this before. There happens to be an inequality. It says it's greater than here, right here. But other than that, we treat this the same way as we would if it were just an equal to sign. So what should I do first? Sure, Snoo? Yeah, how do we do that? What do I want to move? Add 2x to both sides. Everybody good with that? So on the right side, we have 1. What do I have on the left side? 9. We have 9 plus x. What should I do next? Subtract 9. So x is greater than what? Negative 8. Good? Okay. Let's try something else. Well, here's a weird one. X plus 1 is less than or equal to x. I've purposely chosen a weird one. What should I do here? You can already see what's weird about it, right? On this side, we would want to subtract x, which means we better do it on both sides. So on the left, I would have, that is gone, so I'd have a 1. What is x minus x? It's 0. Is 1 less than or equal to 0? No. So when this happens, like when this is completely not true, and we have seen stuff like this before. We've seen stuff like working our way through an equation and it says 4 equals 6. And we know that those don't equal each other. Then we can say, we can put our answer as this symbol, which means empty set. What it means, basically, I'll put this down here, is this is not possible. So it has no solution. This doesn't make any sense. So just putting this symbol would be fine for your solution. Good? So this isn't common. I purposely wanted to choose this because I do think that when you come across something like this, it's going to be tough for you to know what to do with it if we haven't gone through it together. We could also have x plus 1 is greater than x. So I want to compare and contrast. See the subtle difference between the last one and this one? It's almost the same, but this time it says greater than. So let's work our way through this one and see the difference. I would still subtract x on both sides. My symbol stays the same, so I would have 1 is greater than 0. Everybody see how we got that? Is 1 actually greater than 0? Yeah. This time, this actually is true. So we would say, so I'm going to write that down, this is true. We would say all real numbers is our solution, because this ended up being true. And again, just like in the last one, we probably don't want to write not possible over and over again, so we have this symbol right here. Similarly, this one has a symbol as well. It sort of looks like an R, but with 2 lines. That's the symbol for all real numbers. If you don't want to write, you're going to see and use this a lot over the next few years. If you don't want to write out all real numbers over and over again, get used to using that symbol. So it basically looks like a capital R, but it has 2 lines, 2 vertical lines instead of 1 when you're drawing your R out. Questions about that, Hiva? Say that again? I'll have a look. Is that a question in your book? Yeah, I'll look afterwards. Good? Okay. So I'm going to have you do numbers 3 to 10. You're going to do all of them. And I know